So in the last video, we talked about UV, and I mentioned this electromagnetic spectrum. And I said that a UV vis instrument will do just that. It focuses on the UV region, which is where organic molecules will absorb light, and it will also measure in the visible region, which is where colored solutions do their business. So red, orange, yellow, green, blue, indigo, violet. That is our visible portion. So if I've got a colored solution, a UV vis would be a great instrument to kind of pick from to measure those samples with. Now, remember Roy G. Biv. I erased this on accident just now. But we said that above violet is ultraviolet, right? Well, there's going to be another region right in here. This is the red end. And red, if we go below that, we get into an area called infrared. And infrared spectroscopy is going to be another instrument that we have in our laboratory. So infrared spectrometer and IR. Now, you're probably wondering, well, what's the purpose in this now? I mean, if it is a different part of the electromagnetic spectrum, it's probably relaying to it different energy. So what would the infrared do that the UV vis is not doing? So the UV vis is giving us what we're calling a quantitative work, meaning numbers. It gives us concentrations of things. The infrared, it doesn't do that. I can't really get a concentration of something. What it does do, though, is it IDs parts of the molecule. Okay, so what does that mean, really? ID parts of the molecule? Oh, the answer is yeah, it IDs parts of the molecule. And what I mean by that is, let's say that we take ethanol. Ethanol is a 2-carbon chain. It has an OH group, and it's got these hydrogens onto the carbons. CH3, CH2, OH. This is what we call an alcohol functional group. Okay, so you have to imagine the infrared spectrometer as a workout routine. Okay, the molecule shows up to work out, and the molecule is going to work out a different way than all the other molecules. Each one has its own day that it likes to show up to. So for instance, alcohols love pec and shoulder day, okay? And maybe another group on a molecule, it loves cardio. And another group on the molecule, it loves the leg day. Okay, well, different molecules behave a different way, depending on what's on there. But they still show up to work out. They just prefer to work out a certain way every single time. And OH will do that in infrared spectroscopy. So what happens is that in this system, we will expose this molecule to infrared energy, IR light beam, if you want to think of it that way. And this IR light beam will shine onto this molecule, and this molecule begins the workout routine. And OH will go to work. And OH will begin to work out the same way every single time it shows up. And what happens is that that workout routine is shown on a graph in the infrared spectrometer. And if an OH is present, then that particular type of shape will show up every single time. Well, the other groups on molecules, they all do their own thing. Okay? If that OH group was not there, but another group was maybe there instead, like bromine or chlorine, or maybe that OH group is a double bond O, or maybe it's a C double bond O. Who knows what it is? There's tons of different choices that are out there. They each have their own routine that they like to do, and they show up a different way on what we would call the spectrum. It helps us to identify what is on the molecule. So that means I can take a liquid, and I'm going to put a question mark here. I don't know really what it is. And I can run that liquid on an infrared. And if I see this group show up, I can say, hey, it's got an alcohol group. It has an OH group on it at least. An OH is present. I don't know anything else about the molecule, maybe, but I at least know that OH is present. That's the power of infrared spec. All right, now, you're probably wondering, well, what's so special about this, right? Here we have an instrument. It doesn't really identify a molecule. It identifies an OH group. So if I ran propanol or isopropanol, the question is, would it be able to distinguish the difference? So this is propanol. An extra carbon's been added, but it's still an alcohol, right? So it still would show up with this big hump. If ethanol did it, then that OH will do it on that molecule, and this OH will do it on isopropyl alcohol, which is rubbing alcohol. They all would show up the same way. The problem is that over here on the right-hand side of the spectrum, there's going to be a lot of garbage that shows up. I mean, there's going to be lines all over the place. And for us as an analyst, we can't really look at that and take anything away from it. We're not that good. I don't care how many years of infrared spectroscopy experience that you have in a lab, you will probably not be able to look in that area that we call the fingerprint that is very unique to every single compound. It's not going to work. You're wasting your time. You can tell me it's got an OH group, but you can't tell me if it's ethanol or propanol or isopropanol or any of the other alcohols for that matter, unless you use it all the time. Well, because of that, infrared spectroscopy needed some work. We needed to improve it in some form or fashion. We knew that the fingerprints were very unique. We knew that we could analyze samples on them very well. We knew that we could get functional groups to identify with. So we would have clues as to what the molecule is, but we couldn't really identify everything. So because of that, what they did is that they went back and they revisited infrared spectroscopy, and they came out with FTIR. And FT means Fourier Transform. So Fourier Transform Infrared Spectroscopy is a quicker method that I can use for this purpose. And in addition to that, there is an ATR attachment that we have. And ATR is attenuated total reflectance. That's what that stands for. So I'm getting ready to describe that. So we have a box, and on this box we are going to put a sample that's going to represent the sample, and an infrared beam is going to come into the picture, and it's going to do something. It's going to make this molecule work out. Well, if it works out, it's got to absorb this infrared energy, right? If it's leg day and it's going to work out legs, it's going to absorb some of that energy and something's going to change. So not a lot of light will come through during that time, and the detector will pick that up. It sees all of these changes and it begins to graph it. So what happens is that it says, hey, the molecule's not working out, nothing's happening. And then, whoop, something happened here. And then, yeah, it didn't work anymore. And then, it comes down and then it backs up. And then we see a couple of other things that begins to happen over here. And then it comes back. Well, that's a bunch of jumble to you right now. But a trained infrared spectrometer would be able to look at that picture and identify the functional groups on that molecule. Well, FTIR will allow that to take place very quickly. A normal infrared scan takes about 2 to 3 minutes. When we're running samples, we have to wait 2 to 3 minutes in order for that processing to complete. The FTIR, though, will capture everything in about a 30-second or less time frame. The FTIR that we have will do 45 scans every run, and it will average all 45 of these pictures together to make one. And it presents us with a more statistical kind of representation of what this infrared would look like. All right, well, that's good news with FTIR. It makes my job much easier because it's quicker. I don't have to wait as long for it to do its thing. Not only that, but even if I am waiting just a little bit longer, it's no big deal because I'm getting 45 scans all at once. Well, what's this ATR attachment? Well, the ATR attachment is this box that sits on top of the infrared, and on this box will be a platform that will hold a diamond, a real synthetic diamond. Now, how can that, a real synthetic? That doesn't make sense. Okay, a synthetic diamond. This ATR attachment costed us around $18,000. The FTIR was another $25,000 on top of that. And the reason that we purchased the ATR attachment is because this is very well suited for solids and for liquids. It shortens my sample prep time tremendously. A normal FTIR or an IR without the ATR attachment, you're going to have to take a couple of minutes to prep the sample. It goes between salt plates, you got to put it in there, you got to close the door, you got to hit scan, and that takes some time. But the ATR attachment, you put one drop on the diamond and you hit run. Or you put a small scoop of liquid on the diamond and you hit run. There's no sample prep time associated with anything. So it's good news. But in addition to that, we also have a software package. Remember, I told you that the fingerprint regions are completely different. There's no trained person that can look at that infrared region and tell you what that molecule exactly is. Well, that's the purpose of the software now. The software has a database, and it can run a sample, and it can compare it to the database to determine what exactly that sample is. And it will show up on my computer screen. All right, so for instance, a cop pulls somebody over, and a cop finds some white powder in a car. And they say, "Sir, what's this white powder that's in this little Ziploc bag?" And they say, "Powdered sugar." Yeah, it's probably not powdered sugar. If it is, why are you carrying it around in a little Ziploc bag? Are you trying to get a sugar high? No, you're probably trying to get another high. So a cop could take this solid sample, bring it into a lab, and you could run it on an FTIR. And with a matter of 5 minutes or less, you could put that sample on an ATR attachment, scan the sample on the FTIR, cross-reference that picture to the database that's on the computer, and the computer will kick back and it will say, "Oh, this cocaine, it ain't powdered sugar." It will actually identify it. It will give you a name. No, these are the possibles. Number 1, number 2, number 3, number 4, number 5. And then it will list right beside of each name how confident it is about that name and about that identification. We are 80% sure it's cocaine. We are maybe 76% sure that it's this, and we are 5% sure that it's powdered sugar. You get the idea. So it is a great way to identify unknowns. I can't get quantitative data easily from it. There's motions and papers now that are trying to use FTIR to get concentrations with. I'm not saying that it can't be done, but it cannot be easily done. And that's really not what its purpose is anyway in a laboratory. We've got better things to do that with. But this is identification purposes. That's what we use it for. Well, again, we've got a complicated mixture maybe. A complicated mixture comes into the lab. How would it behave on an FTIR? Well, you're going to kind of see some problems with something that's very complicated. But for the most part, if it's kind of a pure compound, there's not a lot of components with it. If one is in higher concentration than the others, then we're going to see no problem at all using an FTIR to identify a solid or a liquid. It doesn't really matter which one it needs to be. Who cares? The power of the software, the database, the ATR, all works hand in hand. All right, so who is the manufacturer of our FTIR system? Well, I'm going to go back to a website that we've already been to, and that's called Shimasu. Yes, we're going back to Shimasu. I told you that we have quite a few of their equipment pieces, and the FTIR is one of those. So under Analytical and Measuring Instruments, we're now going to go up to Products. We're now going to go up to Products. And if I scroll down through here, it's going to tell me some things. Balances, gas chromatographies, liquid chromatography. Hey, look, down here, TOC analyzers. But look, molecular spectroscopy right there. A couple of different versions. Look, they do UV vis spectroscopy. We don't have any of their instruments. We have the thermo units instead. But they do FTIR. So I'm going to click FTIR. Couple of different options that show up over here to the side. What we have is the IR Affinity model, FTIR spectrometer, and there it is. The IR Affinity FTIR spectrophotometer has been designed with teaching and general research labs in mind. So if I'm working for an analytical lab, I probably want something a little bit more precise than this, but it does a really good job for general research. It's compact, fully functional. All FTIR techniques come along with it, in addition to an ATR attachment. We've got a compartment on the front. That compartment will allow us to attach different accessories depending on what we need to do with it. So I'm going to enlarge the screen up a little bit. Here's the FTIR system. Pretty simple, pretty compact, just like it said in the description. And this lid will pop up, and this is where my ATR attachment would go if I'm using one. And if I wasn't using one, my sample would still go in this area as well. So that lid, that's its purpose. That's where the sample is going to go. Whether you do it like normal, traditionally, or whether you put it on an ATR, it doesn't really matter. Notice here, it's hooked up to a computer. It says Lab Solutions IR software has a library of 12,000 spectra. Well, these are 12,000 commonly used compounds that might be out there. Gives me a little detail about the instrumentation, about things that, make their FTIR a little bit better than the others. We just had a working relationship with Shimasu. We feel very comfortable with their equipment. Knock on wood, they've never really messed up too much on us. So we feel very comfortable with the quality of their product. So that's why we went with Shimasu. All right. So there's all kinds of crazy attachments that you can add on to these. You can run gas samples if you want to run gas samples, but that's very uncommon to do. But there are gas containers that you can trap a gas sample in and run them in FTIR, just as you can with maybe UV vis as well. Up here at the top, you see an academic package or a forensics package. So I'm going to click forensics package because that's what most people are kind of curious in. As I told you before, this is something that's very common as far as forensic chemistry goes, because it helps us identify basically unknown compounds that get submitted to a laboratory. Okay. Applications up here at the top, just like with all the other ones, it gives me an idea of what I could use this instrument for to see if it's suitable for something that I am doing in my laboratory. So you'll get to run on an infrared. We have some older models, and the older models do not have ATR attachments. You'll be running those as well. ATR is kind of a bling bling item that we don't want you to take for granted. So you're going to run samples using the old school version, but you'll run samples using the ATR as well. So that way you can understand the full difference between the two different types of instruments. All right, so that's the story with FTIR, and I'm sticking to it. And we're almost finished. We have a couple of more pieces of equipment that I would like to talk about, or technology that I would like to discuss. So we're not out of it yet, but we're getting closer and closer. So don't give up on me. Go ahead, take a bathroom break. Go get some popcorn. Go get a snack. Go get a drink. I hope it's not alcohol. Maybe. If it helps you study better, then by all means drink it. But come back and see me, and we'll finish this up.